Canals played a huge role in the growth of London's economy. In the early years of the Industrial Revolution, the roads between cities like Birmingham and London were atrocious, and this was why the canals got built. In its heyday, the waterways network covered over 5,000 miles and carried some 30 million tonnes of freight across Britain every year. In 1800, the Grand Junction Canal was opened, running from Brentford in London up to Braunston on the Oxford Canal. This was a sort of shortcut, because the old way from Birmingham down to London was to go all the way down the Oxford Canal and then down the Thames. This cut 60 miles off the journey, but it still took 4 days. Nevertheless, in the 19th century, the canals were the motorways of the country. Richard, what was it like in the early days of canals?
There was no hard surfacing on the roads. They were muddy, rutty. Carrying goods by water is quite efficient. The boat carries 25 tonnes or more. That couldn't be equalled on the road.
No, there certainly weren't huge juggernauts, were there? But,
right.
but hang on a sec, they've got to pull this 25, 30 tonnes along.
Yes.
Was it men who did this?
Before they built the canals in the 17th century, they did have teams of men towing boats, yes. But they later used horses and donkeys.
But men could actually pull large loads?
Yes.
Could I pull this boat?
You could do.
OK, I'm going to give it a go. How much stuff have we got on here?
We've got about 16 tonnes.
16 tonnes of sand. And you reckon I could pull it?
And the boat weighs about 15 tonnes.
Oh, so 30?
But you can push the boat with one hand. Just lean on it.
Huh. I'm going to try. OK, watch me. Now then, I'm not at all sure that I can do this. 30 tonnes is an awful lot. OK, Richard, are you ready? OK. Just leaning into it, using my weight. Now, that's 31 tonnes a boat, and I guess we're probably doing 1 mile an hour now. See if we can go a little bit faster. Accelerating. This must be 2 miles an hour. Well, it's very difficult to get things moving. That's because of their inertia. But once it's going, it's not bad, because once it's got momentum, it's not going to lose it. There's no friction. That's the great advantage of carrying freight by water. Anyway, I reckon I've done a couple of 100 yards now, and obviously I could go all the way into London, but I think perhaps I'll let somebody else take over. Oh! I found someone to pull the boat, well, I think, anyway. This is Hector and this is Vicky, and I think Hector's going to do the pulling, is that right?
So.
He has pulled boats before, has he?
He hasn't pulled a boat before. He's pulled lots of other things, but not a boat.
How much can a big horse like this carry on its back?
Well, these horses used to carry the knights in shining armour, so sort of 30, 40 stone.
Wow. So that's about a quarter of a tonne.
Yeah, but for a limited amount of time.
And how much could it pull in a cart?
A single horse will pull a couple of tonnes.
A couple of tonnes?
Yeah.
So how much on a boat?
Probably limitless.
Really?
Yeah.
Now, do you think Hector will pull our boat?
I hope so.
OK, well, let's have a go. Go on, Hector. Steady, steady. It's a big boat back there. I know, I've pulled it. Whoa, that was a nasty shot, wasn't it? I guess they never used to tarmac the towpath, did they?
No, that's right. It's very slippery. Once he realises that it moves slowly when he moves slowly, he'll pick it up. There we are. He's starting to get the hang of it.
Oh, yes, so he has.
Horses are very quick to learn an easy way of life.
I thought they had very small brains.
They have.
It's wonderful to see how Hector's learnt this new skill. He's learnt that walking on the grass is better than walking on the asphalt, and he's also learnt that it's better to go slowly, because then the boat follows along rather than trying to heave along at 30 miles an hour. In fact, horses were so efficient at pulling barges, they were in use until the 1950s, when tractors came in, and then, of course, the boats began to get engines on board. I think he thinks it's lunchtime. But not all canals are straight. So what happened at the bends? You sometimes find a curious thing where the towpath goes from a straight bit like this and then has a kink. The horse has to walk round the corner here, pulling the rope, which therefore pulls against the stones on the corner of this brickwork. So they put up this iron post to protect it. Now, the rope's wet and it's got a lot of grit on it, and it actually wears these grooves in the iron post. Just look at these. Enormous. You could hide your finger in there. Just from a wet rope covered in grit, pulling over the years against this iron post. You can see these all over the canal network. One problem canal builders had to face was the hill. Suppose you came to a hill, you had three options. You could either go round it following the contours, which was obviously a long way round, or you could go straight through it, through a tunnel, but digging tunnels was very expensive, or you could go over the top. Now, the trouble with the third option is that you can't build canals at an angle, because all the water would run down to the bottom end, and here it would be dry and you couldn't get anywhere. You have to make canals dead level. So the only way to go over a hill is by building locks. In the early days of canals, the only thing they had to impede the flow of water was what was called a flash lock. Imagine you're looking along the canal here. Here is basically just a dam. That is a flash lock. And so when it was full of water, the water didn't flow through downstream. But if you wanted to go through this on a boat, well, if you're upstream there and you open the paddle, the boat would go would go thundering through, extremely dangerous. It was liable to capsize, and there wasn't much chance of your being able to go upstream. In the 1500s, they came up with an impressive but simple solution. On the canals today, there are pound locks, like this. They have two pairs of gates with a stretch of water in the middle, which is the pound. And the point is, you can always keep one pair of gates shut so the water doesn't go careering downstream. We want to go down the canal, so we need to raise the water level inside the pound to match the level on our side of the lock. A windlass is used to crank open paddles in the gates, letting in up to 50,000 gallons of water. Only when the water levels are equal can we open the gates. The boat then enters the pound. So now what we have to do is to shut the upstream lock gates, and you'll notice they meet at an angle. So mitered gate, allegedly invented by Leonardo da Vinci. And the point is that then the moment there is any extra pressure from above, that'll push the gates tight together and prevent any leakage. All right, now we have to get the level in the pound down to the level of the canal below. So what we do is to raise these paddles, because there are holes in the lock gates, and you can see the water goes streaming through, and the level here goes down and down until it's the same both here and here. And when that's the case, then we can open these gates, and then we could sail through into the canal below. This is Brentford, where the canal originally met the River Thames. Boats carrying everything from sulphur to aluminium ingots would enter and leave the canal network here. Tom, how did the canal companies make money?
They made the money by charging so much per tonne per mile, depending on the cargo that was being carried.
OK, so if you were carrying coal, then you pay per tonne of coal?
That's right.
OK,
yes.
And what's all this info here?
Well, this is actually a page from a 1924 toll register.
What's this sheep dip? Do they carry sheep on board?
No. I see it's come from Berkhamsted. It's a whole boatload, 34.25 tonnes. It was probably being exported to somewhere like New Zealand.
No doubt. Anyway, now how did they measure the tonnages?
Well, each boat was gauged, so they would take it to a special dock. They'd put 1 tonne weights in, and every 1 tonne they put in, they measured
a line.
And then they would have great big documents, and each boat would have how many dry inches for what tonnage.
So how do they measure the weights?
Well, shall I come and show you?
Yeah, terrific. OK, Tom, what can you measure with this rod?
Well, with this rod, you can measure the number of dry inches.
So the top is about 21 inches, I reckon?
21 inches, yeah.
That's above the waterline?
That's above the waterline. But what you normally did to make sure there was no cheating, you actually measured on 4 corners of the boat.
Gotcha.
So they then averaged the 4, and then went back into the toll office, looked on the charts, and then for a particular boat, that number of dry inches represented a certain tonnage. But roughly for every extra tonne you put on, she will go down an inch.
Okay, so how much is there in there now with 21?
16 tons.
16?
Yes.
That's brilliant. Thank you very much indeed. 1801 saw the opening of a canal extension into central London. By 1820, London was encircled by waterways as the Grand Junction and the Regent's Canal were joined to form a link to the docks. This is the Paddington arm of the Grand Junction Canal, bringing all that trade down from the north. So when they built the Regent's Canal, they wanted to siphon off some of this trade, and so there is the Regent's Canal, deliberately built to join onto this stretch of water. All those people down there wanted to siphon off some of this trade from up north and take it all the way down to the Thames at Limehouse. It was a great business opportunity. The name Little Venice comes from a poem by Robert Browning, who lived nearby. A canny estate agent used the term while trying to sell a property, and the name stuck. This area of London is very built up, so when they built the canal, they had to construct 3 tunnels. And getting through those tunnels without a horse was quite an adventure. Cheers. Cutting through central London is a quiet and largely forgotten stretch of water, now home to fishermen, walkers and pleasure boats. The canals were once the heart of London's transport system. This is the Regent's Canal, a major engineering feat. And because it's going through highly built up places, a lot of it had to go through tunnels. In fact, there are 3 of them. This is the Islington Tunnel. It's more than half a mile long. Now, when you were building a tunnel, you didn't really want to make it so wide that you could put a towpath along the side. So there you had to take the horse round and leg the boat through. Now, I'm not sure I like the sound of that, but let's see how it works. Now, Ed and Maggie, you're leggers, I think. Is that right?
I think we've been volunteered to do that, yes.
You're not going to leg this thing, are you?
We certainly are.
This is huge, this boat.
Yes, but once it's got moving, it doesn't need much effort. It's just the initial effort to get it to move.
Right. So how do you do it exactly?
You lie on your back and you walk along the side of the wall with your feet.
The side? You don't, not the roof?
The side. It depends on the tunnel. You could on some tunnels.
Right.
But on this tunnel, you'd walk from the side.
So, without further ado, we set off into the tunnel. Now, we're just about into the mouth. Could you show me how you do it? Okay, so you lie down on your side and then you just walk. Well, we're definitely moving, not terribly fast, if I may say so. Oh yeah, it's working, isn't it? So you're just walking?
Yes.
Do you think I could do it?
Yes, do you want to have a go?
Oh, yes, please. So I just lie down, all
Slightly
comfy.
on your side.
Yes.
Get your feet up high.
Feet up high, up there somewhere.
High over easier.
Really?
Not too high. That's it.
Oh, hey, that's not too bad.
That's it. You need to push harder.
Harder. Right. Well, it's a bit like walking up a bit of a hill.
You have to work in tandem with the other person on the other side.
Right.
So that you both push the same amount.
Hey, it's rather good. We must be doing...
You must be doing 2 miles.
2 miles an hour, yes. And so we've got half a mile to go. It's only going to take us a quarter of an hour to get through. Faster, Ed, faster.
I'm going fast enough. You've got to go faster.
All right, I'll do my best. I don't want to say anything, but that other end doesn't seem to be getting any closer.
We've only gone in about 80 foot.
Oh, it's dark here. I gave up after about 10 minutes, but it took Maggie and Ed another 20 to get through the tunnel. Luckily, 6 years after the canal opened, a steam chain tug was installed to tow the boats. Most of the traffic on the Regent's Canal carried goods from Limehouse docks. Coal from the north of England and cargo from abroad would be transferred from seagoing vessels to barges and narrowboats. This is Battlebridge Basin, just north of King's Cross. there were basins like this dotted all along the Regent's Canal with great warehouses, because this was where a whole mass of trade happened. Goods would come in by canal and go out by canal all over the country. And in this particular basin, there was one rather unusual form of produce. Right here, they unloaded vast blocks of ice cut from frozen lakes in Norway, and they brought it here to Carlo Gatti's ice house. These ice wells were built around 150 years ago and were in use for 50 years. They used to be 13 metres deep, and they held 1,500 tonnes of ice. Absolutely amazing. What's more, the insulation was very effective, because in all the time from when the ice was cut in Norway to when it was brought here to when it was taken out to the customer, only a quarter of the ice melted. Really impressive, that. Up there, it's a warm, sunny day, but down here, it's cool and quite spooky and extremely damp. Just look at the water running down the wall there. That must be coming from the canal. I hope it's not going to fill this place up, because it's a long way up those steps. Now, the Victorians didn't really have fridges. They weren't available. So they needed ice to keep things cool. And in fact, they used to be taken, all the ice used to be taken from here by horse and cart all over the capital and used by people in cooking, and also by Mr. Gatti and other caterers in making ice cream. Now this, I reckon, is the door straight into the canal. God, it's all rotting, look. Bits of it are just falling off. I think I'm going to move. Thanks to Mr. Gatti, ice cream became available to the public all through the year. And basically, you'd buy a little ice lick like this one. This is a sort of glass egg cup, really, with a tiny bit of ice cream in the bottom. And what you do is you take your lick like this, and then you hand it back to be refilled for the next person, passing on all your germs. Ugh. Thankfully for us, ice licks were banned in 1926. By the 1870s, competition from the railways was threatening the canals. However, there was one cargo the railways were reluctant to touch: gunpowder. The Lee River in northeast London has been used for transporting goods in and out of the city for centuries. And in the Lee Valley, there's a whole complex of hidden canals, especially useful here at Waltham Abbey, because this is where they made the best gunpowder in the world. We're in the Lee Valley here, right? Why was all this navigation business so important?
Well, the importance of the site at Waltham Abbey is that we're about 15 miles or so from the Thames. As along the Thames, it had good connections to the Tower of London that was used for storing gunpowder, and Greenwich, but it was also vital for importing the ingredients of gunpowder.
Right.
By about 1900, there's a network of about 5 miles of canals within this one factory. And this canal network was used to move the gunpowder, or the later high explosives even, between the process buildings.
A mixture of saltpetre, sulphur and charcoal, gunpowder, when ignited, produces huge volumes of gas almost instantaneously, and that's an explosion. Transportation by water was by far the safest option. Why did they start making gunpowder here?
So it was all a way of ensuring that the British had the best quality of gunpowder in the world.
So you reckon that was crucial for the Napoleonic Wars?
It was absolutely crucial, I believe.
Right. So is this gentleman here anything to do with that?
I think he may be.
Well, let's go and see. Excuse me, sir, who are you?
I'm Corporal Sherwood of the 2nd Queen's Royal Regiment of Foot.
And are you about to go and shoot somebody?
I'm about to shoot the conkers off the tree.
Well, yeah, but that's presumably not what you're paid to do.
No, I'm going off to Spain to fight the French.
Ah, the Peninsular War. You're loaded with black powder.
I am.
And grape shot. What else have you got?
I've got a ball down there.
You have? Oh, all right. I'll stand well back. Missed. Close. You frightened it. You certainly frightened the starling out of the back of the tree. Well, that's terrific. Thanks very much indeed, and good luck in Spain. Well, transporting the gunpowder by water was as safe as they could do, but it wasn't totally without risk. In 1874, the centre of London was rocked by an enormous explosion. In the early hours of one October morning, a barge, the Tilbury, was being towed along here in this deep cutting on the northern edge of Regent's Park. As it went under Macclesfield Bridge, the 5 tons of gunpowder on board blew up, and there was a colossal explosion. The whole of the top of the bridge was lifted off, rubble went heaving into the air, damaging houses hundreds of yards away. In fact, the keel of the barge, the Tilbury, was blown into the air with such force that it fell on a house and went all the way through to the cellar. All the residents came running out thinking there was an attack. The bang was so loud it was heard 20 miles away, and the horse cards came galloping up thinking there was an Irish insurrection. It's been called Blow Up Bridge ever since. These cast-iron pillars, made in Coalbrookdale and presumably brought down on the canals, actually survived the explosion, although they were knocked over. If you look here, you can see more of these grooves where the ropes from the barge horses wore their way into the iron. But have a look on the other side, and you'll see there are grooves here too. And obviously these were the original grooves, and then after the pillars had been knocked over by the explosion, they were put up the other way round in order to equalise the wear, if you like. In the 1930s, the canals were joined together to form the Grand Union Canal Company in an attempt to fight back against competition from road and rail. But it was too late, and the canals went into decline. The end of freight carrying on the canals came with the big freeze in the winter of 1963, and all the water here was frozen solid. No barges could move for 3 months, and all the trade simply evaporated. Luckily, more uses have been found since then, obviously recreational uses, and also on the towpaths. Down here, there are thousands of miles of electricity cables cooled by the water from the canal. It was thanks to the efforts of enthusiasts that the canal's fortunes have been slowly revived. These once commercial waterways are now welcoming recreational use. When the canals were first built, nobody wanted to live anywhere near them because they were regarded as a grubby arm of industry. But now there are masses of pleasure boats, and living by the canal is highly desirable. And in fact, these houses are exceedingly exclusive. Even a mooring here costs something like £7,000 or £8,000 every year. Mind you, I wouldn't mind living here. Perhaps I could just sneak in between 2 of these boats.